Hello and welcome everyone to the Intrepid Museum's live virtual programming. Thank you so much for joining us today for our live program, Biome Away from Home. I'm so thrilled that you could tune in with us today. My name's Alicia and I'm an educator at the Intrepid Sea, Air, and Space Museum in New York City. I'll be your host today. And just as a reminder, the museum's live streams are free, but if you'd like to support us in delivering programs just like these, please click on the link that you can find in the comments or in the description. So feel free to use the chat today to say hello. Let us know where you're tuning in from, or maybe if you've ever been to the Intrepid Museum before. And of course, if you've got any questions, you can put them in there as well. Now, our museum, the Intrepid Sea, Air, and Space Museum, is located in a historic World War II aircraft carrier that also served during the Cold War and the Vietnam War. And we have a lot of really cool airplanes and helicopters and a submarine even. But, often when people come, they wonder, all right, well, I understand why you're a sea museum and why you're an air museum as an aircraft carrier, right? But why are you also a space museum? Why do you have a space shuttle on your flight deck? So believe it or not, a long time ago in the 1960s, the Intrepid served as a prime recovery vessel for picking up NASA's space capsules. Way back when NASA was just getting started and they were launching these space capsules up on rockets, well, eventually when they would come back down, they would land in the ocean. And of course, the capsules and the astronauts inside of those capsules had to get picked up again. So the Intrepid was actually one of those aircraft carriers that was able to go and pick up a few of those missions. And so that is why we have this really cool connection to space, and also why we like to talk a lot about space too. So today we are going to talk a little bit about planets in space with an eye specifically towards what is needed to support human life. And we're also going to be using a really cool website called Solar System Scope to do it. So let's get started with our journey together. So everyone, take a look here. All right, so tell me here in the chat if you happen to know, what are we looking at? What is this blue marble here? Anyone happen to know? This is, of course, Earth. It's where we live. It's where we are right now here in the universe. But also right now, this is the only place that we have ever found life as we know it in all of outer space so far. So I do like to start here to talk about why Earth is so special. Now, planet Earth is able to keep us alive for a few reasons. And tell me in the chat if you happen to know why. What are some things here on Earth that keep us alive? What are some of these basic things that we need in order to survive? Anyone know? You can look at this picture, you can look around, see some of that blue stuff. Maybe that's a good hint to start off with there, or even think about that big kind of shell around it as well. Maybe we've talked about this in other programs too. So some of these things, everyone, first of all, you can think of that we need to breathe air, right? Oxygen, more specifically. We need something to keep that air close to the planet, to keep it all contained so it doesn't just escape out into space. So the first thing, of course, our atmosphere, very important. We also need water to survive and to keep our bodies healthy. And we also, of course, need comfortable temperatures too, right? We need to, be far enough away from the sun so that we don't burn up, but also close enough that we don't freeze. So we want to be kind of in that Goldilocks zone, not too hot, not too cold. So if you said any of those things, great job. That is a good starting place. And these are some really key things that we need to support life here on Earth. So with all this in mind, do you think that maybe there is anywhere else in the neighborhood of the solar system even that we could live? And also, if humans can't live there, what sort of life might be living there already? So let's take a look at the solar system, shall we? So everyone, using this program here, we can take a look, all right, at our solar system. We are going to look at our neighborhood here. And there we go. Now, we know the planets, of course, go around the sun. They rotate in orbit around that center point of the sun. So first of all, where did the sun come from? Well, scientists believe that a long time ago, there was this big cloud of dust that was floating around in outer space. Then, we don't know, something happened, all right? Something maybe collided with it, Maybe there was another dust cloud that kind of flew through it, and it began to all combine and join together. So these pieces of dust just smashed into each other, making these larger pieces of dust, kind of like how you might think of like a snowstorm. You've got all these snowflakes that are, flying around everywhere, but then they might crash into each other and make some bigger snowflakes. So eventually, all of that dust kind of settled into the middle of that cloud, and that was the beginning of our star, the sun. And then, of course, it got bigger and more things collided with all of those dust pieces. And it also started to pull more and more things towards it and also around it. And so a bit further away from that dust ball, then smaller clumps of this dust started to form. And these began to become our planets. Now, these collisions also, when they're happening, create a lot of energy. So you can imagine a bunch of little explosions on impact every single time. And the clumps that are closer to the sun, well, a lot of those planets form pretty quickly, and a lot of that gas got whipped away. So the 4 closest planets to the sun are what we call rocky planets, whereas the gases stayed and kind of were more collected near the back of the solar system. And those are what we call our gas planets. And now these, my friends, of course, then become our solar system, all of these together. So let's start off by talking a little bit about the center of our solar system. All right, we are going to take a look here at the sun. So here we go. Now, the sun, everyone, is a pretty massive star. Let's go visit the sun here. Pretty massive star. Let me ask you a question. You can put your answer in the chat for me. What percentage, all right, so this is going to be a number between 1 and 100. What percentage of the solar system's mass do you think the sun is? Now, when I say mass, I mean everything. So every planet, everything on each planet, every asteroid, every moon, every rock and person and house and everything we own in our houses, our clothes, our gadgets, all of that here on Earth too. All of this is mass. So taking a look at the sun here, what percentage of the entire solar system do you think the sun makes up? Go ahead and give me a number in the chat between 1%, which would be just a teeny tiny little bit amount, or 100%, which is the entire solar system. And there's nothing else in the solar system at all. Anyone have any guesses for me? All right, I see a couple of numbers. Some guesses. All right. So believe it or not, everyone, the answer is 99.86%. All right. And Vashton, I see you said upper 90s. That is a very, very good guess. Very close there. Upper 90s. Yeah, 99.86%. So that is of all the mess, all of the stuff in the solar system. And that is huge. All right. Now, it's also very bright, right? Researchers once thought that it was just another insignificant star in our Milky Way galaxy, but it is actually now considered to be brighter than about 85% of all of the other stars in our galaxy. So that's also really important to consider if we're going to be looking for other Earth-like planets outside of our solar system. And that is something called an exoplanet. And we'll get a little bit more onto those later. Now, because of this giant mass of the sun, it does attract other things towards it and around it. And it has, of course, the planets like Earth that orbit around it too. So let's take a look now at one of the planets, the first planet. You might have heard us talking about this particular one in some of our other programs. We are going to take a look now at Mercury, the very first planet. All right, so we've got Mercury right here. And let's go explore Mercury. Now, Mercury, everyone, if you take a closer look, you fly in here. There we go. Mercury, if you look at it, it actually looks a little similar to something that maybe you've seen already in the night sky. Anyone know what it kind of might remind you of looking at it here? I know certainly when I look up in the night sky, I see a big round, most of the time. Sometimes it's a little bit of a crescent shape too, but I see, a round shape up there and it's bright and it's glowing in the night sky, right? So, it does kind of look like the moon, right? So this is Mercury. It is named after the Roman messenger god Mercury. It is the closest planet to the sun. And because the sun makes all of that stuff swirl all around it, well, a lot of that stuff is also crashing into Mercury. So it is also the most cratered planet with all of those kind of, points of collision there, all of those big holes. So it's got all of these craters around it, these big dents. But here's another question for you. The Earth takes 365 days to go around the sun, right? One orbit around the sun. That's 1 year for us. Now, keeping in mind that the sun's mass attracts things the closer they are and makes them move a little faster the closer they are, how many days do you think it takes for Mercury to go around the sun? Mercury, all right? So pop that answer in the chat for me if you want to take a guess. Give me a number. How many days do you think is 1 year on Mercury? And again, its speed might have something to do with how it got its name as well. All right, that Roman messenger god. You see him a lot with wings on his hat and on his shoes, right? So he's, kind of their mailman, and he's known for being pretty speedy at that. Any guesses? You could probably guess maybe it's a little faster than Earth. So generally, everyone, the further you go out, the longer it's going to take a planet to go around the sun because it's going a bit slower. So if Earth takes 365 days, it's going to be less than that. And the answer is it only takes 88 days for it to rotate around the sun. So that's about a quarter of the time it takes here on Earth. That's about 3 months in our time. So you'd be about 3 times older than you are here on Earth if you lived on Mercury. Now, Mercury doesn't have an atmosphere, though, all right? And because of that, it's got a lot of these craters, right? A lot of things smashing into it, but also it can get up to about 800 degrees Fahrenheit on the side that's closest to the sun, but also negative 400 degrees Fahrenheit on the side facing away from it. It doesn't have the atmosphere to help to spread the heat around it so evenly like we do here on Earth. So thinking about that and thinking, of course, about how the atmosphere is very important for us here on Earth, do you think we could live on Mercury? Probably not. Those temperatures are still pretty extreme for us as humans, and it also doesn't have the other things that we need, like air or water, too. So we can continue on our adventure here, exploring the solar system. We'll move on to our next planet. The next planet, of course, you can take a guess, but you probably know, Venus. All right, let's fly to Venus. All right, so here we go. We are flying to Venus. Excellent. Now, Venus is known as our sister planet because it is actually smaller in size to Earth. And it also is actually, or similar, not smaller, excuse me, similar in size to Earth. And it also is the only planet named after a female deity. So Venus was the Roman goddess of love. And interestingly enough, it's also the only planet that rotates on its axis the opposite direction as it goes around the sun. Now, unfortunately, we cannot live on Venus for another reason. Now, even though Mercury is the closest planet to the sun, Venus is still the hottest planet. And it's for the same reason that our planet gets warmer each year, greenhouse gases. Now, there is a lot of carbon dioxide and other greenhouse gases that get trapped inside there. It's all the sun's heat inside of Venus's atmosphere. It's all boiling up there. So that is, an instance of an atmosphere that's actually making it harder for things to survive, or at least humans anyway. The other issue, of course, is that the surface is covered in volcanoes that happen to spew out toxic fumes as well. So, yeah, while it is kind of pretty, it's, in fact, it's actually one of the brightest objects in the night sky next to the moon. It's also not somewhere that we could live, unfortunately. So I'm going to pause here now after we've talked about the sun, we've talked about Mercury and Venus. Do we have any questions so far? Let's see if we've got any questions that we can take care of off the bat. What's the sun made out of? So the sun's mostly made out of helium. That's that stuff that you put in birthday party balloons to keep them floating up, right? So it is about 3/4 helium. And then the rest of it is made out of other elements, things like carbon and iron and neon and oxygen. So all of that stuff produces an immense amount of heat. And in fact, the surface temperature of the sun is over 10,000 degrees Fahrenheit. For those of you tuning in overseas, that's about 6,000 degrees centigrade. But if you actually, keep in mind that it doesn't really, again, have a surface per se, it's just this huge ball of gas that's burning. So 99% of all of the power of the sun actually comes from its smaller core. And it's surrounded by something called the photosphere. So that's kind of like a very thin atmosphere. But even though it's got that atmosphere, it is way, way, way too hot for us to live actually on the sun. So good question, though. Any others? Why does Venus rotate backwards? That's a great question. And actually, scientists are still trying to figure it out. They think originally it might have spun the same way as the rest of the planets, but that for some reason it flipped its axis 180 degrees to go in the opposite direction at some point. Basically, it's just upside down now, and it looks like it's going the other direction. But when it flipped, they aren't sure. It could have been due to some really strong pressure of Venus's atmosphere. Its atmosphere, actually, it's about 92 times stronger than what we have here on Earth. So it could have had something to do with that, or maybe the sun's gravitational pull might have, moved it somehow. It is closer to the sun than we are. But again, they just really don't know. That's just, a theory about the fact that it flipped. There's also a theory that it didn't flip, that it actually just eventually slowed down to the point where it stopped at one point. It was still going around the sun, but the rotation of it actually on its axis. There's a theory that, it just stopped and then just started going the other direction at one point. So we don't know. That's a good question. Now, everyone, the next planet, of course, we all know and love is Earth, right? So let's go take a look one more time at Earth. Oop, that's not Earth. There we go. Flying here into Earth. Of course, we're already on Earth, so we don't really actually have to fly. But here we are on Earth, all right? Now, there is something around Earth that we can't see with our eyes necessarily while we're here on Earth, but you can kind of see it here. It is that beautiful light blue layer around the Earth. All right, so I mentioned this earlier. This is our atmosphere. It's very, very important to us, very, very essential to life on Earth. You can imagine if the Earth was like an egg, you can think of the atmosphere kind of like the thin eggshell around it, right? But there's something else that's even more invisible that we don't even think about. Now, the inside core of the Earth, and I can actually show you this here. Here we go. The inside core of Earth here, it is made out of metal, all right? Molten hot iron and nickel, and it creates something called a magnetic field around our planet. And that's really important because it helps to protect us from particles that are shooting out from the sun. Now, as they come towards our planet, well, those particles, they can be really dangerous. They can actually even strip away our atmosphere, of course, what we need to survive. And once they get through, well, of course, that's why they tell you to, wear your sunscreen, right? It can hit our bodies. It can get into our DNA. It can cause some serious mutations, some serious health problems for all living things too, not just human beings. But that magnetic field causes those particles coming from the sun to bounce off and to shoot away in other directions into space. Now, sometimes they do get through that magnetic sphere and they do interact with our atmosphere. And when that happens, it can cause something pretty neat to happen in our sky. So does anyone out there know, what do we call it when that happens? All right, tell me in the chat if you know. It's when the ionized particles from the sun, they come in and they actually interact with our atmosphere. Sometimes it can cause some really cool colors to appear in the sky, often surround the north or the south poles. You see those colors kind of dancing in the sky. Anyone happen to know? It starts with an A. You don't know how to spell it, Vashton? That's all right. It's the Aurora Borealis. There's a lot of letters in that, I know. The Aurora Borealis, or the Northern and Southern Lights. Yeah, so that's actually what happens. That's when you've got these charged particles from the sun that slip through the magnetic sphere and they actually interact with our atmosphere. So, it's kind of nice to look at them, even though you don't necessarily want to have it on your body all the time. Now, the Earth is located, as I mentioned, in a very special location in our solar system. So you can see it here. It's about 93 million miles, or about 150 million kilometers from the sun. And it's within that very special zone that I mentioned, where water can exist as a liquid on the surface of a rocky planet. All right, so you can see as I zoom out here just a little bit, this very special place right here. All right, so water can exist. We call this region here a habitable zone, or the Goldilocks zone, because again, it's not too hot and it's not too cold for human life. Now, every star actually has one, but they can be further out or closer depending on the brightness of the star. So, our habitable zone here is actually perfect for Earth because of, again, the brightness and the size of our star. Now, Earth is also the first planet from the sun that has a moon. All right, so we did mention before that Mercury kind of looks like the moon in our night sky, but we can check out the moon of Earth as well. Oh, here we go. Let me go back to this. All right, so let's check out Earth's moon right here. And again, at the end, everyone, I'm going to tell you about this site a little bit more so you can explore it yourself. So here we go, zooming into the moon. Now, have you ever noticed, everyone, as you look up into the night sky and you can see the moon, have you ever noticed it always kind of looks the same? We always see the same craters and things like that. Maybe you haven't noticed that, but I challenge you now, if you happen to go out and look at the sky, you're going to always notice it always sort of looks the same. Of course, we say like the man in the moon, right? Yeah, you always kind of see the same pattern. So it's spinning around Earth, right? It's on its axis, but why do we always see just one side? Well, the moon is something called tidally locked, and that means that the same side of it is always going to be facing in towards Earth. So while we rotate away from it during the day, so of course the sun is out, we don't see the moon, it's actually still facing us on one side. But when we rotate towards it at night, it's also still there facing us. So it does orbit on its path around us, but remember, it's still going around us too. So since we're both moving at the same time, we actually only ever see one side of it. It's a little confusing to think about, but it's imagine if you and a friend were facing each other and then you both turned away and then you both face forward again. That's kind of what it's like, where you only ever see the other person's face. Now, the next planet, of course, in line is Mars, a planet that's been getting quite a lot of press lately. Because, of course, we just landed our Perseverance rover on the surface a few months ago. So let's go ahead and check out Mars, the red planet. All right. Here we go. Visiting Mars. Now, we can get to Mars a lot faster in this program than we can in real life, of course. There has been a lot of talk as to whether Mars maybe might have had some life on it at one point a long time ago, and whether or not humans could live there in the future. While NASA does have plans to put astronauts on Mars within the next few decades, we have to wonder, is it the kind of place that we could actually live long term? Well, let's think about it. All right, here's Mars, right? The red planet. It got its name because it looks like a big, red, angry eye. So they named it after the Roman god of war. Anyone happen to know why Mars is red? You can put it in the chat for me. Why is Mars red? What do you think about that? So we have been lucky, of course, to have a number of pictures of Mars because it is so close to us. And that was actually really helpful for Perseverance in particular, the rover that we just sent up while it was landing. So we knew exactly what the terrain was going to look like. And if you look around, you can see other surface features too. So we know Mars has some towering volcanoes. It's got some big canyons, but it's also got, the highest mountain in the entire solar system too. It's actually larger than Mount Everest. But the surface of Mars is red, and I see Wenyan Witkowski says rust. That is absolutely right. It's covered in iron oxide, basically rust. It's the same thing that would happen, if you left your bike out in the rain. It would start to get a little brownish, a little red, a little rusty. That's that iron oxide reaction. When iron gets a little air in it, it's oxidized iron, so iron oxide. And that is why Mars looks red. That's what it is all over it. Now, the reason I brought up the magnetic field before, though, is because looking at Mars is kind of like a science experiment for us. When we look at it, we can see what might actually happen eventually to our planet. Now, Mars, it's similar, but it actually doesn't have a magnetic sphere anymore. There is, though, evidence that it did once have one, which meant that Mars may have also once had a very thick atmosphere at one point, too. So our past Mars rovers have seen that they even think that it might have even had oceans or of liquid water and weather even at one point as well. So that is why Perseverance is so, so cool. Its primary mission now is to look into this exact fact more. So really searching for possible signs of past life, exploring, what they believe was once an ancient river delta specifically, and a lake around the Jezero crater. So that's really exciting for us because, again, here on Earth, water is one of those essential things that we need to support life. And well, if there was once life at one point, who knows? Maybe we'll find something on Mars too. So Jezero crater is actually located right about here. A great tip for helping find it if you are looking at a map of Mars, or a picture of Mars, I should say. If you look for its ice cap, of course, a very, very cool feature of Mars, and you look here, you can see kind of this chevron shape right underneath it. It's kind of like an arrow pointing you straight down, and then boop, right over here is where Jezero is. Now, of course, we don't know that there is life on Mars. And all of this also doesn't mean that anything even used to live there, but it just means that Mars had many of the things that we know we need to support human life. It does still have an atmosphere, but it's much, much thinner than ours. And it's actually 95% carbon dioxide. So it doesn't really do a great job to, shield its surface from those solar particles that I mentioned earlier, or also to keep liquid water in place. Obviously, we haven't found, lakes or rivers or anything like that on Mars right now. But also, while the temperature in the summer gets to be about 70 degrees Fahrenheit, which is super nice here on Earth, that's about 20 degrees Celsius during the day. At night, it can plummet to about 200 degrees below zero. Fahrenheit. So it's about negative 130 degrees Celsius. But all that said, it is still really fascinating to us. And we certainly want to know more about this place and, see if maybe other things used to live there too, or maybe even still do. We just haven't found them yet. So next up on our tour of the solar system, if we pass through, of course, the asteroid belt, the next one that we would go visit is the big daddy of them here, Jupiter. So here's Jupiter, the king of the planets. Now here's a question about Jupiter. If we're looking at this right here, can anyone tell me what that big red spot is right here? Tell me in the chat if you happen to know. That is one of the most famous markings of Jupiter, that red spot swirling around on it. Right around there. Anyone happen to know what that red spot actually is? Yes, you got it, Vashsin, a storm. It is a giant, giant storm. Jupiter has been impacted by comets, but that red spot is actually a storm and has been raging on for hundreds of years. And actually, ever since scientists started observing it, they have noticed it's starting to go away. It's actually decreased a little bit in size since we've started looking at it. So who knows? Maybe one day it'll go away completely, or I don't know, turn into something even crazier. But Jupiter is what we call a cold gas giant. It is the largest planet in the solar system. It also has a ton of moons. It's got 79 of them right now. And we'll talk a little bit more about moons in just a bit. But something else that's very interesting to note about Jupiter is that it spins faster on its axis than any other planet. And because of that, there are very, very high winds. So that's why you can actually see those swirling bands of color around it. Now, Jupiter also has a huge magnetic field, but there is no surface to Jupiter. The magnetic field is caused by its largely liquid hydrogen mantle, but otherwise, it's just predominantly gas. So Jupiter, it is actually very cold. It's 180 degrees or negative, 180 degrees Fahrenheit. Not to mention it's also pretty violent, of course, with all of those storms. So yeah, no surface, really cold. Probably don't want to live there either, right? So we can continue on our tour of the solar system, see what else we can find here, see if there's any other places that might look good for us. The next one we would want to look at here then, of course, is Saturn. Now, Saturn is just gorgeous, right? Probably one of the most notable ones with those giant rings. But when you look at it, it's kind of startling to look at it and see just how thin those rings are. Look at that. So we see it usually, like this. Looks like these giant rings, really pretty, right? But when you look at it dead on from the side, it really is kind of a shock to see just how thin those rings are. They can almost disappear when you're looking at them like that. Now, The rings there, it's really just a bunch of dust and rocks and ice. So a lot of debris orbiting around Saturn. Actually, a really good depiction, though, of what the solar system looked like early on while it was still forming. So if you imagine the main planet part of Saturn, the round part, as the sun, and then everything else swirling around it, that's actually kind of what the solar system was like early on. Now, did you know that Saturn actually, though, has even more moons than Jupiter? It has 82 identified moons right now, but arguably maybe as many as even 150 that they are still identifying. So, science and planetary science, it is not a finite thing. We are still learning new stuff every day, still identifying new things every single day. And Saturn's and Jupiter's moons are certainly one of those things. Now, Saturn is also a gas giant. Also, it doesn't really have a surface. It's primarily gas too, which is really, it's something I always think is so interesting. You look at these, it looks like a solid mass out there, but it's actually just gases all held together. But again, it's also very, very cold as a result. That one is about 200 degrees below zero. And it also, as you can imagine, it's further away from the sun, takes longer to orbit around than we do on Earth too. So it's about 29 years to go around the sun. The winds on Saturn also move 5 times as fast as those even on Jupiter, which I mentioned move very, very fast too. So again, maybe not the best place for us to be looking for a new home on Saturn, unfortunately. But the moons, we'll get to that in just a little bit. All right, so next up, our next planet after Saturn that we could identify then, of course, is Uranus, right? All right, so let's take a look at that one. Really pretty color here, right? All right, so you can see Uranus. Now, when we go there here, we might actually see something that surprises you. It also has a ring around it. In fact, all 4 gas giant planets out there have rings, believe it or not. They're just different sizes. And, maybe you didn't learn about that in school, so you don't really associate it the way you do with Saturn. But yep, Uranus, Jupiter, Neptune, they actually all have rings too. Just again, a little smaller. Now, when we take a look, it does seem a little bit bizarre. If you were to look at Uranus, this is actually how it is situated. All right. Now, it looks a little different than Saturn when we're looking at it here in regards to the rings in particular. So that ring, it almost looks like it was knocked on its side, doesn't it? Compared to Saturn. So Uranus actually has a 97-degree tilt on its side. Now, we don't know for sure why. Scientists think that something big, maybe even planet-sized, hit it and knocked it onto its side like that. So, a long time ago, they think that this might have happened, but now it's actually the only planet that rotates on its axis this way. And so it's really special. Now, what's cool about Uranus is that because of its chemical composition and pressure, scientists think that it actually might rain diamonds there. And that there are even oceans, maybe, of liquid diamonds. All right. But before you go and pack your bags, you got to know Uranus is extremely far away. And it is also, as a result, very, very cold. It is about negative 350 degrees Fahrenheit. It is the coldest planet in the solar system, which, of course, is also incredibly bad for us humans if we want to live there. Also, it would take about 84 years to orbit the sun. So you're going to be really old before you have your first birthday if you were to go and live on Uranus. Now, the last planet, everyone, of course, planet in our solar system is Neptune. So let's take a look at Neptune. All right, now it is, of course, even further away. It is a beautiful blue planet, though. Look at that. Gorgeous. But it also, if you look closely, has another spot on it. Look at this. It's another storm. This is the great blue spot, as opposed to the red one on Jupiter. So I bet you didn't know that, or maybe you did. Neptune also has its own blue spot. Now, of course, Neptune was named it after the Roman god of the sea because of its lovely blue color, just like the ocean. And it is so far from the sun that since it was discovered, it's actually only ever made one orbit around the sun. It was discovered in 1846, and this one takes a whopping 165 years to orbit around the sun. It is pretty slow. Now, Neptune was actually discovered in a very interesting way. A long time ago, scientists were observing Uranus and they realized it wasn't exactly moving the way they expected it to. And the only explanation that they could think of was that there was something else that was about planet sized messing with its orbit. So they did a lot of math. They decided, all right, based on our calculations, it looks like, well, okay, there should be a planet right about here. And then they decided to, point their telescopes in that very specific spot and really crank it up. And sure enough, that is how they found Neptune, right about where they expected something to be. So Neptune, believe it or not, was actually discovered thanks to math. Who knew? So there we go. So that is Neptune, of course, the last main planet in our solar system. And I know I saw Vashsin says cries in Pluto. We'll get there in just a second. But before we get on to that, I want to pause here and see if we've got any other questions about our main planets today. Let's see. Is there water on Mars? So no, we haven't found any liquid water on Mars yet, but there has been evidence, of course, that there might have been at one point. They did find signs of water in the rock layers and even deposits of sediment on the surface that have minerals that can be found in water. And the surface also, it kind of looks like there might have been these huge floods billions of years ago that collected in these huge canyons and these big craters. And so, there's also signs of frozen water, though, of course, near the South Pole, that icy cap that we were looking at, too. So that is why, it's really exciting. We're going back now. We've got the Perseverance rover up there. We are now, more than ever ready to look into this and collect some amazing samples and to see what is actually up with the water situation out there. Is it under the ground? Is it, hidden away in like a rock somewhere? Like, they don't know. And, they're thinking too, it'd be really, really great. Same thing with the moon, actually. They were thinking about if there's a way to take the minerals that they could find in these rocks and somehow, combine them up and make water. That would be really great to be able to live longer as well. Even taking some of the particles, the hydrogen particles that are coming in from the sun and, mixing them up with some oxygen, H2O, make some water. They're coming up with really creative ways to possibly be able to live long term out there. But nope, as of right now, no liquid water has been found on Mars just yet. All right. Any other questions? Is there, there we go. How big are Saturn's rings? So we saw that they're actually pretty thin. First of all, they're only about a half a mile thick. So when I was, moving that shot there, you could actually see they really just sort of disappear before your eyes. But really, it's how wide they stretch around Saturn that is so magnificent. And those pictures that we're used to seeing with those gorgeous rings. Wide-wise, they actually stretch on to about 200,000 miles wide. And again, they're just a bunch of dust and ice that are spinning around it. But because of what they're made out of, they can reflect the light of the sun really, really well. So that's what makes them shine and sparkle so brightly for us when we look at them through a telescope. All right. Now, many of you here today, may have learned that there are 8 planets and that Pluto is not actually a full-fledged planet in our solar system. When I was growing up, I learned that it was. So it's only fairly recently that it's been demoted. But believe it or not, Pluto, it is actually now classified as something else. And if you're someone my age, it's hard for us still to comprehend. Does anyone know what it is now currently classified as? Anyone know? Tell me in the chat if you know. And while you're typing that in for me, I'm going to go ahead and pull up Pluto for us as well. And I actually have to go and look a little differently here. There we go. All right. So we're going to zoom out here and we are going to pull up Pluto on here. But yeah, does anyone happen to know what Pluto is now considered? What do we classify it as? There we go. Pluto. I'll fly to Pluto. So Vashsin, you say an exoplanet. Close. It's still within our solar system. So it's not technically an exoplanet, which would be outside of our solar system, but it is something else. All right, here's Pluto, everyone. See that cute little heart spot? Pluto, everyone, it is super far away. Like I said, it used to be a planet. a main planet, I should say, but it is now classified as something else. It is now called a dwarf planet. Now, why is that? What is a dwarf planet? Well, there are three main criteria that make you a planet. All right, you have to orbit around the sun, you have to have a round shape, and you have to clear your orbital path. Now, that means that if you are going around the sun, there cannot be anything else around you close by that doesn't also orbit you. So, for instance, the moon orbits around the Earth, right? Well, nothing else is in its way there. But nothing else is, orbiting around the moon either. So when it comes to Pluto, while it does have 5 known moons, they do orbit around Pluto, but they also kind of orbit around each other equally as well. So because of that, it doesn't technically completely clear its orbital path. So it got demoted to being a dwarf planet, unfortunately. Or maybe not, unfortunately. I don't know. Does Pluto have feelings? Maybe. I don't know. But, if we let it be a full planet, we'd have to then think about all these other dwarf planets that we have. They'd also have to be full planets. We'd have to rewrite all of these science books. It would be kind of a huge mess. So that is a more specific classification that they could give Pluto, calling it a dwarf planet. But Pluto is still very, very interesting. It's very icy, as you can see. And then, of course, it's also got, like I said, that cute little heart-shaped ice cap. So we do love Pluto, and Pluto does love us back with its little ice cap there. But like Uranus, Pluto is also considered to be lying on its side. So it is at about 120-degree tilt, which means that its seasons, if you are familiar with the way the seasons work here on Earth with its tilt on its axis, as you can imagine, the seasons are then also very extreme on Pluto. So the solstices, so that's the shortest and the longest days of Pluto's year, a quarter of the planet is in constant darkness or constant light on the solstices, all right? 100% of the time. It's also, of course, extremely cold. Now, it is very, 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 very far away from the sun. So it's about 375 degrees Fahrenheit. And again, because it's so far away from the sun, it orbits a much slower pace, 248 years to fully go around the sun. So very long seasons there as well. But that is, planets then, and some of the restrictions that humans might face living on the other planets in our solar system or the dwarf planet. But, why limit our search for habitable planets to just human life to start, right? Life on Earth takes on some very wild and very varied forms. So might there be a place where we can find some life in outer space? We may need to actually stop looking for life on planets and start looking at things like moons instead. So let's take a look at a couple of moons to get started with that exploration. All right. So we are going to now look at Jupiter's moon, one of them in particular that has been very interesting. This is Europa. All right. So looking at Europa here, and actually you can see Jupiter in the background there. Let's take a look here at Europa. This is one of the largest moons of Jupiter. It might kind of look like, a lifeless ice ball, but you might notice something kind of interesting on its surface here. All right, all of these scratches here. Now, underneath this frozen, cracked exterior, Europa actually has a secret. Oceans, all right, liquid water, and actually potentially even more water than there is here on Earth. Now, the Hubble Space Telescope actually spotted geysers, these things called cryovolcanoes, that when we were looking at Europa, they saw. And these geysers, they're not, like Old Faithful here on Earth. They don't shoot out hot, steamy water, but rather they're kind of more like cold volcanoes, okay? They eject water and ice, specifically, so cold water, about 125 miles off the surface of the icy moon from this icy crust here. So it does have an atmosphere and it does have water. So could there be life there? We don't know. Maybe. Now, certainly it wouldn't be life like us. It wouldn't be humans. But some of the things that are necessary for life as we know it are there. Now, let's take a look at another moon that's also very, very interesting to scientists right now. It's a moon of Saturn. This one is called Enceladus. Oh, not that one. Hold on a second. This one's called Enceladus. All right. Again, another moon of Saturn. Here we go. Here we go. All right. So looking at this one now, a little different. Saturn actually has two moons that might have life. Enceladus is one of them. And it also has, again, those plumes coming out of its surface at its south pole. In 2005, we actually sent an orbiter, the Cassini orbiter, and it was able to take a closer look at these massive geysers of water that are shooting out from the south pole of this little icy moon here. And it even flew directly through the plumes too, which is very cool. And it was able to collect samples and detect organic molecules. So again, not life necessarily, but things that life needs to survive. So things like carbon, for instance, very essential here on Earth. So again, it has an atmosphere, and this icy crust here has water underneath it. So who knows? Maybe there's something. Now there is another one that we can look at. If I zoom out here, we look at another one that's around Saturn here. This one right here, Titan, also very, very interesting, and something we're interested in looking at here. Let's visit Titan. All right, so this moon of Saturn, there we go. This one actually might be the most interesting of them all. So Titan is Saturn's largest moon. It's the second largest in the solar system, actually, but that isn't the only thing that makes this particular one special. All right, so Titan has an atmosphere, and it's actually much thicker than Earth's. It also has oceans. It also has land. It's got terrain features. So, hey, it might have life, right? But we can say 100% certainty here that it is not going to be life like we have on Earth, because all of that stuff I mentioned, those rivers and oceans and land masses and even weather, it's all made out of methane. Now, methane is incredibly toxic to humans. The Cassini orbiter actually used infrared imaging to look through all of these clouds, and they spotted a world, like I said, rivers, lakes, seas of liquid methane, rain even, right? But again, methane, not great for us as humans. But we do know that here on Earth, deep, deep in our oceans, we've got these underwater vents that pump out methane under the water. And there are actually organisms that hover around those little vents, and they eat it up. They thrive off that methane. That is their, that's their jam, man. That's what they do. They eat methane for breakfast, lunch, and dinner. So, hey, if life has evolved here on Earth to eat methane, maybe it's also evolved to do the same on Titan. We don't know, but it's really interesting, and something else, of course, that is just awesome to investigate as we continue to look for other places that we could survive. Now, everyone, with the advent of the Hubble Space Telescope, we actually have been able to look more closely at our solar system. Of course, we learn more, but we've also been able to travel using pictures outside of our solar system and to look at places that are even beyond our Milky Way galaxy. Now, we can't take a picture, unfortunately, of our galaxy because we are in it. We haven't traveled anywhere near out that far just yet, but we can take pictures of other galaxies nearby. We can look at their stars. We can see if we can find things called, as I mentioned, exoplanets or exosolar planets. Exoplanets for short. So as we zoom out here, you're going to notice we're getting really far away from the sun. We can zoom out all the way out here, and this is what we think is our Milky Way galaxy. Here we go. Now, these, planets that orbit another star, these exoplanets, so not the sun, but another star that is maybe like the sun. We do know, for instance, there is a place called Fomalhaut b that we've been able to take some very basic pictures of. It's very, very far away. And there's another system that we know of called the TRAPPIST system, which actually has 4 planets in its Goldilocks zone away from its star. So again, not too hot, not too cold. Could be something interesting there. And we think that they might have originally been ocean worlds. So part ice, part ocean with an atmosphere a lot like Earth. So, hey, maybe there could be life on those planets. We just don't know. We're still exploring, but it is a really, really great place to start, and something that makes a lot of sense as scientists. If we're looking for a home away from home or a biome away from home, then that's a good place, to start from, thinking about what we 100% need to survive. Now, as of July 1st of this year, so just earlier this month, there are 4,777 confirmed exoplanets. So again, this is a planet orbiting another star somewhere. Plus, though, they still have another 5,000 candidates that are still to be confirmed from a variety of other missions to make sure that they are, in fact, planets. But of those we've confirmed, scientists actually think that about 60 of them might be habitable based on those factors that we talked about today. So we are definitely just scratching the surface of these planets right now. There is still so much that we don't know. But with the James Webb Telescope eventually going up, maybe at the end of this year, we hope, we will be able to get, an even better look into just the depths of our universe and begin to maybe start answering some of these questions and maybe get one step closer to finding out if there is, in fact, life out there. But of course, with every question, we've always got so many more that pop up too. So only time will tell. So everyone, that concludes our program Biome Away from Home for you today. I might have blown your mind just a little bit, but maybe this offers, an opportunity for you to get a little inspired and ask some of your own questions there. I do want to see actually if we have any last questions before we wrap up as well. Do we have any other questions maybe about exoplanets or anything like that? Oh, yeah, great. Have we ever visited an exoplanet? No. We only have an idea about these distant planets based on what the data from our telescopes tell us, things about their size, how close they are to their star. But that's also really important to point out, too. It's that, let's say that we have to abandon Earth for some reason, some horrible reason that would make us do that. I don't know. And so let's say we decided that we wanted to travel to one of these exoplanets that's within a habitable zone and has an atmosphere and has water and all those things. You also have to consider the time it would take for us to travel there, right? So you might think, there could be, 2 maybe habitable exoplanets within 10 light years away, all right? That might, again, big question here, might be able to support us. We don't know yet. We still have to actually test it out. Now, 1 light year is the distance that it takes light to travel in 1 year. So that is really far away. That light moving at 700 million miles per hour, right? Our spacecraft goes fast, but it doesn't go that fast. Apollo 10 was actually the one that set the record for the highest speed at 25,000 miles an hour. But even at that speed, going 25,000 miles an hour, it would still take you about 270,000 years to go 10 light years away. So sadly, we would not even survive that trip. We need to figure out how to travel at light speed or faster at this point in order to even consider something like that. But who knows? It might be possible someday. Now we have rocket ships that can land themselves. So who knows? I'm sure someone will come up with something who'll be able to travel at, light speed like you see in the movies, maybe in our own lifetimes. How incredible would that be? All right. Any other questions? How many exoplanets are there? We don't know. Again, right now we have, just over about almost 5,000 confirmed exoplanets. Doesn't mean that they're habitable, though. But if you want to really consider how many potential exoplanets might be habitable, even very, very far away, you can kind of think of it like this. Okay, a solar system like ours is based around a sun, right? And the sun is a star. So scientists are discovering new stars every day. But so far, they've identified over, I think the number now is like 70 sextillion stars and counting. Obviously, they're finding new ones every day. So to understand that a bit better, there's this idea, if you took every grain of sand on every beach here on Earth, so every little tiny, itty bitty little piece, all right, you counted them all up, every tiny little grain of shell and, broken bottle or anything that's on the beach these days, right? You would still have more stars than even that. Every grain of sand, you still have more than that. So you might suggest that maybe there could be at least 1 exoplanet in each of those stars' orbits that is in a habitable zone, not too hot, not too cold. So, that could give you an idea of all the possibilities. If there's 70 sextillion, who knows how many are in it? We've got more than 1 in our habitable zone. Of course, they're not all habitable, though. But it really is mind-boggling to think about, right? It really makes you wonder if there could be even another Earth out there somewhere, or maybe even hundreds or thousands of them even. We have no idea. No one knows. So if that doesn't make you feel small, I don't know what will. So on that note, everyone, I would like to thank you all so much for joining us today. I would like to point out the website that I used today, actually. It is called Solar System Scope. There's the website. I just put it up for you there. Feel free to take a look around there. You can look at, the stars and the planets and dwarf planets and moons, just like we did, even some constellations and a whole bunch more on there. So definitely check that out. And everyone, if you have any other questions about our programs, you can reach out to us through our website, intrepidmuseum.org, or also through social media. So be sure to follow or subscribe to this channel and visit our website for our upcoming programs. And if you enjoyed this or any of our past programs, we would love your feedback. There's a link in the chat that we encourage you to click on to answer a few questions that'll help us to plan for our future sessions. So everyone, our next family program is Tuesday at 3 p.m. It will be Intrepid Women. We are going to be highlighting the anniversary of the founding of the WASPs, the Women Air Force Service Pilot, with a special program about some incredible women in air and space history. So once again, that's this Tuesday at 3 p.m. right here on our streaming platforms. So once again, thank you so much for joining us today. Hopefully we will see you online for another upcoming Intrepid adventure. Thanks so much, everyone. See you next time.